Good morning to all of you. Yesterday we were in the calculation of center of mass, so today we would like to continue from there only. The calculation of center of mass. So I think first point we have discussed. Center of mass in short we will write COM, the center of mass of system of particles. Center of mass of system of particles. This already we have done in the last class. So if you remember, the relation was there: RCM is equal to your M1 R1 plus M2 R2 plus M3 R3 and so on by total mass M1 plus M2 like that. And then we can write in terms of your X, Y and Z coordinate also. This we have done. So this was the center of mass of particles. So normally we are using two particle system most of the time. So we will calculate this separately. Center of mass of two particle system. Center of mass of two particle system. Only two particles. Here in the first case, number of particles are there, n number of particles. But here we will take two only particles because this is very commonly used case. So this is one particle M1 and this is M2, and these two are at a distance here. Let R0. Okay. And now we have to find the position of center of mass of the system. Method is same as we have done in the first case. Same method. It means position of center of mass. Position means always it depends on the reference point. So first we have to decide reference point. Anywhere you can take, but here it is convenient to take reference point at one of the mass itself. Let reference point here itself, and since only two masses are there, so these two masses can be joined with one line, and that line can be set either x-axis, y-axis, or z-axis, anything you can say. So let this is your x-axis. So center of mass must lie on this line. Let this is the position of center of mass. COM is this, and this is at distance here R1 from mass M1, and let R2 from mass M2. Okay. So we have to find which value? R1 in fact. Okay. So if this we are considering as an origin 0, 0, now you can simply find XCM, position of center of mass of X coordinate in x-axis, M1 x1 plus M2 x2 by total mass. M1 x1 0, M1 into 0 plus M2 x2, x2 is from here to here, which is your R0. M2 R0 by total mass M1 plus M2. So FCM is the position of center of mass, which is nothing, which is equal to your R1. So R1 is equal to here M2 by M1 plus M2 into R0. This is the distance. It means position of center of mass from mass M1 will be at a distance M2 by M1 plus M2 into R0. And from mass M2, how much distance? R2. So from mass M2, which is your R2, and R2 is nothing, R0 minus R1. And substitute the value of R1 from here. So you will get R2 is equal to your M1 by M1 plus M2 into R0. Okay, so this is the relation. Now if I am looking here, R1 by R2, see from R1 by R2 you will get M2 by M1, M2 by M1. M1, R1 is distance from M1, M2 distance from R2 distance from M2. So I can say generalize. If I am generalizing this, there is one more thing. Okay, let's see here. If M1 greater than M2, if M1 greater than M2, so M2 by M1 will be less than 1. See here, R1 by R2 is equal to M2 by M1, and M2 by M1 is less than 1. So R1 less than R2. See important point. If mass is more, M1 is more than M2, distance will be less. It means center of mass will be close to that body which having more mass. Okay, getting idea? So we can write this point here. Note, center of mass will be closer to the body which have more mass. Okay, or we can say one more thing, or we can say it means mass is more, center of mass position will be less. Mass is less, center of mass position will be more. It means mass and position of center of mass from that mass is your reciprocal. One is increasing, other is decreasing. So we can say R is proportional to 1 by M. Just like here, M1 R1 is equal to M2 R2, which is, you can say, constant. So R is proportional to 1 by M1. It means center of mass will be closer to the heavier mass and farther from the lighter mass. The center of mass will be closer, it means R will be less, if M will be more. If M is less, R will be more. The center of mass will be closer to heavier mass and farther from the lighter mass. Okay, just note down this. So these points you have to remember, because so many times we will use two particle system. Okay. Okay, now come to the next point. Center of mass of extended body. Third point, center of mass of extended, or we can say continuous body. Continuous or rigid body. All are the same name. Center of mass of extended or continuous or rigid body. It means, in fact, we are going to calculate center of mass of our practical bodies. Earlier we have done for a point mass, particle, but none of the body is your particle. All are your rigid body. Extended mass is not at one point. Mass is distributed. So since mass is distributed, that's why it is called your extended mass or continuous, and the distance between any two particles is your constant. That's why it is called your rigid body. Rigid body means any 2 points in the body will always remain at same distance. That is called your rigid body. So this is in your random shaped body. Okay? In this body, how many particles? Infinite particles are there. So it is just like a system of, first case, it is just like a system of n particles. So all rigid body or extended body or continuous body can be assumed as a system of your n particles or infinite particles. Okay? How to calculate? The total mass of this m. The total mass your m. So this body can be your linear body. Linear body means just like a slender rod. It can be your two-dimensional body, just like a disc, just like your lamina, just like your triangular plate. So it can be a two-dimensional as well as it can be a three-dimensional also. Three-dimensional means it can be sphere, cylinder, cone. Okay. So it can be any type of body. So if it is your laminar body or linear body, only one direction, x-axis, any x coordinate or y or z we have to calculate. If it is your plane body, just like your ring, disc, we have to calculate two coordinate, x and y. And if it is your three-dimensional, so all the three we have to calculate. But method is same as you know, xcm, m1 x1 plus m2 x2 like this. So one I would like here to see here. This has been made from number of particles. These are the particles. Infinite number of particles are there. Okay? Infinite number of particles are there. And this is the reference point. One particle this, another this, like this. These are the distances. I am generalizing this one. One is at R1 distance, another R2, R3, R4, like this. Okay? And this particle, total mass your m. Total mass is your m. So one particle let have mass your m1, m2, m3, and these particles are small mass. Small particle is very small amount of mass. So one of the particle let have mass, I can say dm1, which is your distance your r1. Another your dm2, this is your r2. So RCM, how to calculate RCM? I remember M1 R1, R1 into dm1. Okay, plus R2 into dm2. Likewise, divided by total mass. Total mass means okay, clear? Next, this is the summation of product of R and M. The summation symbol I am using Ri dmi. I value start from 1 to n. I remember this. I think you know. Summation we can write like this. Divided by same summation of mass dmi 1 to n. So this becomes the total mass. So 1 by total mass capital M. Now this is nothing summation of product. Summation of product means it is the integration. You don't know this. What is integration? Area. Summation of area. Area means product of two quantity. X and Y or any two quantity can be there. Same thing. R and M. Product of two quantity. So if I am making a graph between R and M, so area of that graph or curve give us product of R and dm or M. And the summation, it is summation of area. That is nothing, it is the integration. It means from here integration has been derived. Integration which you are doing in the mathematics, this is the definition of integration. Okay, see, then this I can write with the symbol RCM. Now this R we can replace with the integration symbol RDM by total mass. This is the general formula for finding center of mass of your extended or continuous or rigid body. So R means position of center of mass of that point which having mass your D. R1, R2, R3, these are the position of center of mass of those small particles which are having mass dm1, dm2, dm3, because particle center of mass will be at the place of particle itself. The particle size is infinitely small. So there is no two different points in case of particle, but in rigid body there can be three different points are there. The particle center of mass will be at the position of particle itself. Okay. So RDM is nothing. R is the position of center of mass of a small particle which we are calling as in integration language. DM is nothing. It is a small element. Okay. DM is what? DM is the mass of a small element. When you are calculating area, x dy area is like this. X dy. What is dy? Small element. Remember integration, you know integration all of you? Basic integration? X dy. So dy is first we are making a small element. Same thing here we are assuming a small particle which having mass dm. That is called mass of the element. And R the location of that center of mass. So we can write here R is the position of center of mass of element of mass dm. Okay. Now this if you want to replace in terms of x, y, z, so R can be said if you want to calculate x coordinate of that, it become your in place of R it will become your x. x dm by m. Similarly, ycm y dm by total mass, zcm z dm by total mass. In this form you can write. Okay, understood? So first I told you this is the formula. In this relation we have to put the value, then we will integrate, then we can get the answer. So I will solve some problem, then you will get the idea how to do this. So note down this. Okay, so same flow. Now see the application is how to calculate with the help of this. So first example, center of mass of uniform slender rod. Okay, uniform means mass, uniform means mass distribution uniform. Slender means thin. It means diameter of that is negligible. Just like a wire. Diameter we are not considering. If diameter is not negligible, then the rod becomes your cylinder. What is the difference between the rod and cylinder? There is a difference. Rod means diameter is very small, negligible. And if we are considering diameter, then it is called as a cylinder. Okay? So slender means thin. So uniform means mass distribution uniform, slender rod. So this is your rod. This is your rod. It means we are not considering its diameter. And mass of the rod your M, length is your L. Now, first point here, can you guess where could be the center of mass? After middle point. Yes. If you remember, I told you, if uniform body given or uniform distribution of mass is there, so center of mass will be at the geometrical center. So geometrical center of this rod will be at where? At the middle. It means at from one of them L by 2 distance. L by 2 distance. Okay. So I think there is no need of calculation. But since these formulas are there, I want to show you how this result can come. L by 2 is the answer, no problem. So center of mass of the rod will be at L by 2 distance from any one of the end of the rod, either from here or from here. Now how to calculate? Rod is one dimensional or two dimensional or three dimensional? Which one? Two dimensional. Two dimensional. Rod is one dimensional, two dimensional, three dimensional. Three. Three. No one is saying four. Rod is your one dimensional. A rod, what I told here, uniform slender rod. A thread, a wire is your one dimensional or two dimensional or three dimensional. What I told you, slender means radius or diameter of this your negligible. It is just like a one line. It is just like a line. If a diameter is negligible means its thickness is your zero almost. If thickness is zero, then it becomes your one, it's like one line. So it is your one dimension. If it is not thin, then it is a cylinder. Then it becomes two dimensional. Or a three dimensional, then cylinder is two dimensional. This marker is two dimensional or three dimensional? Tell me, two dimensional. What is how you are differentiating two or three dimensional? How you are differentiating? In common practice, if breadth and length is there, then only two dimensional. If breadth, length and thickness is there, then three dimensional. This is the length, this is your thickness, this is your depth. Depth means inside. How many dimensions here? Are simple yes here. This is your what? Circle. Disc. This disc is two dimensional or three dimensional? Two dimensional. In the disc, some length has been extended. One more dimension has been added. So two dimension is the disc, three dimension if the length has been extended. Cylinder is three dimensional. Disc is two. Rod is cylinder rod. Cylinder rod is one dimension. So as I told you, if one dimension there, so you can calculate only one of the parameter, either x or y. You can put your rod along any of the axis. Along x-axis, so only your x require. If you are putting your rod along y-axis, so y require. If you are putting your rod like this, z. Let this is the origin. This is your x and y. So we want only which coordinate? X here. So as per the definition, x here. X dm. X dm means take a small element which having mass dm. Small element is just like a particle. I took a small particle here. This have mass dm. And x is the position of its center of mass from the reference point. So this is the reference point. X is this distance. By total mass m. Now, if I am taking this element somewhere here, the x value will change. As the position of dm changing, x changing, there are two variables here, mass and x. So we can integrate only when we can convert this into single variable. How to convert single variable? See, this is the mass dm. Let this small, although it is a small thickness, but the thickness is like dx. So dm is the mass of dx thickness of length. dm is the mass of dx part of the length. No? So how much we can write dm? Total mass m in length n, mass per unit length will be m by l. So mass of dx length will be dm is equal to m by l into dx. Substitute here x dm this m cancel. L is your constant, you can take outside. Now limit from where to where? From here to here. X value, minimum value of x here 0 and maximum here L. So integration of x with x square by 2. Substitute the limit. This will be on L square by 2. So xcm will come here. L by 2. It means center of mass of the rod is at distance L by 2 from one of the end of rod. But in which case? Uniform. Okay. See, another example. In that case, I am not using uniform rod. See, another example. Center of mass of non-uniform rod. Non-uniform rod. Let linear mass density of rod is changing. Linear mass density of rod is given as lambda is equal to lambda naught 1 minus lambda naught 1 plus ax, or simply we can write lambda is equal to 1 plus ax or 1 plus making it more simple, x square, where x is the distance from one end of the rod. One end of rod. Okay. Now, linear mass density given. It is mass per unit value, per unit length is given. See, this is your rod. Let length of the rod your L. And from here we have to calculate 0, 0. Then how to calculate? As per the definition, xcm x dm by dm. Dm is total mass. We will integrate, then we will get total mass. Now, how much x dm? Dm is the element at distance x, dx is the thickness, dm is this. dm is means mass per unit length given. Means unit length have mass this. So this length have dx. So dm will be 1 plus x square. This is the mass per unit length into dx. Substitute 1 plus x square dx. Here also you have to substitute dm 1 plus x square dx. Now integrate. Limit of x 0 to L. 0 to L. 0 to L. Check it. XCM. 0 to L limit and is expanding x plus x cube dx 0 to L 1 plus x square dx. Now integrate separately. Integration doesn't mean you can cancel this. It cannot be cancelled like this. Denominator and numerator you can cancel. So if everything cancels, what is left? Integrate first. X square by 2, x to the power 4 by 4 by x plus x cube by 3. Then substitute the limit 0 to L, 0 to L. See, L square by 2, L to the power 4 by 4 by L plus L cube by 3. And now simplify. So I'll simplify here. So you can write 3 by 8 2L square plus L to the power 4 by 3L plus L cube. Now 1L cancel. So 3 by 8 then what is left? 1L cancel. 1L you can take outside. 2 plus L square by 3 plus L square. Okay. So this is the difference. This is the difference here. Understood? So what is the main objective of this? It is a non-uniform topic. It is a uniform. So in case of uniform at the geometrical center, but this is not the geometrical center because total length of the rod right now also L. Geometrical center will be at the middle, L by 2. But mass is not uniform because mass as x is increasing, then the value of lambda you are increasing. It means here mass is more, here mass is more, here mass is more. So slowly from here to here mass is continuously increasing. The center of mass is here very close to this end. So 3L by 8 plus this term is, into this term will come. So that is close to this end. Okay, because initially here when x was 0, then lambda was only 1, minimum value of lambda here. But as you are going other end, and x value are increasing, lambda increasing means mass per unit length is your increasing. Okay, so it means that this rod has not been made from the same material. Okay. So it has been made from different material. So in here, since material is different, that's why its density is your changing. If it is the same material, the density will remain your same. Okay. This rod was made from the same material. This rod is made from the different material. Continuously material is changing. Okay. So our objective was just to calculate the use that formula. See, this is a very simple problem. Now see one another. This you have to remember, not this result, because this value will change as this is changing. So for uniform body, you have to remember some result. Just like result for the rod. The result for the rod is L by 2 distance from one of the ends. Next, now center of mass of uniform ring and uniform semicircular ring. Okay. Uniform means again mass distribution here. This is your uniform ring. This is your semicircular ring. Uniform ring, uniform semicircular ring. And R radius is also you can have R radius. M is the first. Yes, in case of uniform ring, where will be center of mass? As I told you, where? Geometrical center. So geometrical center means at its center. And I told you this is the one way. Another I told you, if you are able to make two or more than two symmetrical lines, and then the center of mass will be at their point of intersection. So here you can make one line, another line, third line, fourth line, number of lines which are passing from the center. So center of mass of the uniform ring will be at their center. So I will not calculate in this one. Easy one. Main I will calculate uniform semicircular ring. Center of mass will be at its center. That is geometrical, okay, center. But in case of uniform semicircular ring, yes, can you guess? Yes, very good. So in this case also one idea I told you, if you remember. Here we can make one line which is symmetrical to this body. That line is your vertical line passing from the center. This line. No other line can divide the body in exactly two parts. Any other line can divide? No. So in that case I told you one idea. The center of mass must be on that line. The center of mass of the ring must be on this line. It may be here, it may be here, it may be here, it may be here. Anywhere. That we have to calculate. So how to calculate? From where? So normally we can select a reference point. We are taking as the center as a reference point. Now, if this is your y-axis, so what is needed only? Which coordinate we have to calculate only? Y coordinate. Because it will be only on y-axis. No need of calculation of x and z. So let this is your reference point, and we want only y coordinate. Somewhere center of mass may be there, that we will calculate. Okay. How to calculate? Same method. YCM. YDM. Total mass. dm is what is dm? dm is the small amount of, dm is the mass of a small element. Element where we have to take? In the body we have to take. Body is his ring. Mass is here only. No? Mass is here only. So let this is your small element. Okay. This is your dm. let this angle theta, this will be your d theta. So what is the length of this element? R d theta, because length of the arc is equal to radius theta. D theta is equal to length by arc. Length of the arc by radius. So length of the arc is equal to r into d theta. See here. Y. Y means y coordinate of center of mass of the element dm. So y coordinate means this value. This is your y na? This is your y na? How much is? This is the radius r. This is your r cos theta in this triangle. This will be how much? R sin theta. Y is your r sin theta. Dm. Dm mass of this element. Total mass of the ring was your m, and length of the ring was how much? This length pi r. Total is the 2 pi r. Half of the ring pi r. So dm is your mass by total length pi r into length of this part, r into d theta. Understood this point or not? See, dm is equal to your mass per unit length. Length pi r, mass m, mass per unit length pi r, and this length is your r d theta into r d theta. M by pi r into r d theta divided by total mass. Simplify. 1m cancel, 1r cancel. What is left? R by pi left. R by pi, then sin theta d theta. Now this element goes from here to here. When the element is here, then theta value is 0, the limit 0. When element reaches here, then theta is pi, the limit is pi. 0 to pi. Understood? Here. Next, what is the integration of sin theta? Anyone? Integration of sin theta? Minus cos theta. Yes, correct. So minus you can take outside, minus r by pi cos theta, then limit your 0 to pi. Minus r by pi cos pi minus cos 0. Minus r by pi cos pi or minus 1, and cos 0 also 1. So this becomes your 2r by pi. This is your y same. This result you have to remember. 2r by pi. From where? From the center of ring. So center of mass of the ring will be somewhere here. This distance your y cm. This is your center of mass. And this y cm is how much? 2r by pi. The center of mass of semicircular ring will be at a distance 2r by pi from the center of ring. So this result you have to remember. Okay. Next. In the next class I will ask all these formula which we are deriving. At least derivation you should know, but result is you have to remember. Similarly, so I think that for symmetrical body, just like a ring and disc, we do not require, because the center of mass will be at this geometrical center. but this was not symmetrical. So that type of body required. See another example. Center of mass of uniform semicircular disc. Semicircular disc. See, what is the difference between the disc and ring? In case of ring, mass is only on the circumference, just like on a line. But disc is like this. This is the total mass. Everywhere mass is there. No? So here mass is your linear form. Mass distribution in the linear form. Here mass distribution in the areal form. Areal means in the area. Let center is your O. Radius is your R. And M is the total mass. Now first point. Center of mass of the semicircular disc. Can you guess where it could be? Center of mass. See, as just like there. Yes. If we are able to make such line here, this is exactly divided in two parts. So center of mass must be on which line? On y-axis. Just like this. I am taking the center as the origin. X and y. Only what is required, y coordinate is required. Now, very important point here. Our formula again. We will use which formula? YCM, YDM by total mass. DM is the mass of the element. Now depending on size of the element or shape, which type of element you are taking. See. This semicircular disc can be said the number of semicircular disc ring. Number of semicircular ring of increasing radius kept one over another, and then it can form a semicircular disc. And center of mass of ring already we know. So we will take our element of the shape of ring. See, I took one of such ring of radius r, thickness your dr. This is our ring. Ring is as our element. Mass of this element your dm. So first I would like to calculate what is dm. Total mass of this is spread in the area. How much area? Pi r square by 2. Pi square area of the circle. The half of that. So mass is spread in how much area? Pi r square by 2. And dm is the mass of this element. What is the area of this element? Length of this ring is your pi r. Thickness your dr. The length into thickness, pi r into dr. Understood? So dm I can say pi and pi will cancel. So dm I can say 2m by r square r dr. This is dm. And y means center of mass of the element of mass dm. Our element is this ring. So what is the y value for this ring? 2r by pi 9, not capital R. This ring has radius small r. So 2r by 2 is small r by pi. So now substitute here. Y 2 small r by pi dm 2m by r square r dr by total mass m. 1m cancel. Constant term I can take outside. Y is here. 2 through 4 by pi r square I can take outside. 4 by pi r square I can take outside. In this r square dr. Limit of small r. Small r changing from 0 to capital R. 0 to capital R. 4 by pi r square r cube by 3. So capital R cube by 3. So after solving you will get 4r by this result you have to remember. This is for center of mass of uniform semicircular disc. Understood? So note down this, and tomorrow I will discuss some more such type of body and very commonly used body. These all result you have to remember. So please note down, and after that this tomorrow I will continue from here onwards. Thank you. Thanks a lot. Hold on.